Good evening, everyone who join us today physically and via Zoom platform through the remotely places. On behalf of the Water Forum of the IESL, I warmly welcome you all for this webinar. In this year, sorry, in the year 2001, on 11th September, the whole world watched in horror the terrorist attack in USA that left nearly 3,000 people dead in three cities. On 11th September 2023, exactly 22 years later, again, the whole world was saddened to hear the news of two dam failures in Libya. It was not a terrorist attack, but realized that it is a gross negligence of those responsible on safety of the dams. The wounds after such a catastrophic event will not heal for generations. In Sri Lanka, we experienced a dam failure on a sunny day in 1986 April, when Kandale Dam breached that caused 129 people to die. While dams serve immense service to the world, they pose high risks associated with unimaginable consequences should they fail. So, Water Forum thought it is the best time to make a wake-up call and start a dialogue among the concerned parties to identify the lapses in our system. We invited Engineer Dr. Nihal Vitarana to talk on this subject. Based on his wide experience over 40 years in many countries. After his presentation, two Sri Lankan engineers who made efforts to introduce new dam safety approaches to Sri Lankan system will share their thoughts very briefly as a prelude to the discussion we plan today to follow. So, my dear participants, dear ladies and gentlemen, I kindly request this audience to joining us through Zoom to keep your microphones muted during the presentations, and please post your questions in the chat box so that our main presenter and the discussant will be able to answer these questions during the question and answer session. Therefore, my dear ladies and gentlemen, to moderate this event, I would like to warmly invite Engineer Bhadra Kamaladasa, the chairperson of the IESL Water Forum. Dear Madam, the stage is yours.
Thank you, Janaka. I'm sure that brief introduction will be sufficient for the proceedings today, and Dr. Vitarana and other resource persons will elaborate more on this subject. So without going into more details of introduction of the subject, I'd like to introduce Dr. Nihal Vitarana to the audience now. I'm sure most of you know him through many presentations he has done to IESL, and also joining us in many inspections on Sri Lankan dams. So Dr. Nihal Vitarana is currently an independent technical consultant with 40 years experience in dams and critical infrastructure associated with water. Not only that, transport, mining, and various national and international jurisdictions. So his expertise spreads over geotechnical, structural, seismic, and durability conditions of dams. He serves on many technical committees and sits on safety monitoring and evaluation panels associated with dams, energy, and transport projects. He has undertaken more than 450 dam safety reviews and currently an advisor to the largest mining conglomerate in the world in their portfolio of water and tailing dams. He is a graduate of University of Morocco and holds a PhD in structural engineering from University of Canterbury, New Zealand, and the ME in geotechnical engineering from University of Sydney, and MBA holder from Deakin University. Nihal will outline the general legal framework consequences and risk assessments, dam break assessments, and criteria for reducing the risk based on ALA principles, which is usually called as low as uh, reasonably practical level. So, with this introduction, let me invite Dr. Nihal Vitarana to start your presentation. We will share the screen from here, Dr. Vitarana.
बहुत देर हो गई कौन पढ़ाई Can you hear me now? Hello?
We can hear you.
Okay. Yeah, thanks a lot. Can you hear me?
Yes, we
Hello?
can hear you. I
Okay,
can hear
thanks.
you.
Yeah, okay. It had problem. Anyway, thanks a lot for the introduction and the hiccup with the system. So getting back to this one, this is will be an insight into dam safety management and accountability as experienced in this part of the world, Australia, New Zealand, and North America from my experience. And what happened? I was on holiday, and of course, everybody knows someone on the news everywhere. Electrical engineers say it is safe, and let us run the mini hydro. Few people, including, asked me to give what called a voice cut. I only know the haircut, so I said I don't know about it. But again, I can't talk on things which I don't know. So I said I'll give a general view of how they do dam safety engineering in this part of the world. So, um, next one, please. So, what basically this is insight into safe dams management practices expect from their owners and accountable if things go wrong. If you own anything, there's an owner, and there, if something goes wrong, there should be somebody accountable. They can't hide behind a door and say I didn't know about it. And also, second point, in dam engineering is very complex, and dam engineer need to have uh, in-depth experience in few areas and a good knowledge on the other areas. So if I'm a civil engineer doing dam engineering, I should know what's the mechanical and electrical audit, two-phase, three-phase instrumentation. So, for example, as an example, Australia, they expect a dam engineer to sign off on even a drawing, need to have minimum 20 years experience. Anything else can get in trouble. Of course, people can do without 20 years experience, but if something goes wrong, there is no way they can justify their case. Now, one particular thing with dam engineering is sometimes worse than geotech or not complex than geotech or tunnel engineering. It has every dam is unique, so we can't apply a standard and say if I'm engineer, I use calculation against sliding using a standard, so I am off the hook. No, um, the law expect you to know what you are doing. Standard is just a guideline only. Next one, please. Next slide, please. Now, I thought I'll put this one. Of course, somebody owning a dam, the life can be very difficult. So this slide I got from a small. Next one, please. Don't change it. Please go back to the first one. Yeah, please stay. Please stay until I say next. Otherwise, get complicated. So, as he said, no friends after something goes wrong. As you know, trial by the media and also nowadays YouTubers. Even sometimes YouTubers ask me to give a voice cut when I was in Sri Lanka. Then independent inquiries, like here, we didn't have an incident with any fatalities, but the dam was shown to be deficient, and there was a royal commission and prosecuted the engineers. And when something goes wrong, insurers always try to find some deficiency in what you promise, how you manage the dam. I'm involved with a lot of insurers and the owners. That's what the insurer looking at it, so that they cannot pay the bill or the claim. Then class action by those affected, like Australia, there are lawyers who do free class action. That say, if you win it, if I win the case for you, you give me a cut. So if you got 5,000, say $1,000 a person, if they win, that's 5 million. So that's how it works now. And also, everybody will say you should have known better. So we all are smart hindsight. And also, he said no friends before something goes wrong either, because maintaining a dam is expensive. So that not prudent or efficient by economic regulator. They think you spend too much money on this dam and you are burdening the taxpayer. And so one may say too conservative. That will never happen, because some people believe still. I am in Sri Lanka. I have seen people say 20-year flood is one. If it comes this year, they say it won't come for the next 20 years. It doesn't work that way. Sometimes people say conservative, they have no clue. And also there's a thing, let's deal with it when it happens. In that case of dams, you can't tell kids, probably your parents will get killed. If it happens, we'll sort that out later. It doesn't go that way. Next one, please. Next slide. When I thought I'll put this one to loosen up the audience, when dam fails, reaction can be deadly. People think somebody made something and it failed and killed them. For example, in Hungary, a mine dam or bauxite holding wastewater failed in 2012, killing 10 people and burning many, I think somewhere 400. Its storage capacity is only 1 gigaliter. 1 gigaliter is 1 million cubic meters. I don't know how you calculate that in gallon. Compared with, I think your seminal wave is 250 gigaliters. So in this case, the dam break wave was only 1 to 2 meter high, not even higher than the average person head level. Seminal wave, I haven't seen any dam break. If they have, better to share it with the audience or tell where it is. The dam wave, when it breaks, could be up to 30 to 35 meter high. That's more than 12-story building. Imagine that moves farther valley. It will take everything with it. So in case of Hungary, I got few friends. I asked them too. They said they immediately, as soon as it happens, the police put all the directors in the jail. I said, how does it work? They haven't even produced before in a judge. He said that's the safest place for them, because villagers were looking for them to probably, skin them alive. So if you look at Romania, they kill the dictator straight away on the balcony. So they don't take any prisoners in that part of the world. So in 2019, 10 years later, 10 officials were convicted, and I think for jail for negligence. This case is in the internet if you don't believe me. Next, let's go to the next one. Next one, please. As I said, dam is not a lovely pet. It's an expensive beast. So you need to know what you own. It's like probably owning an elephant. It's expensive, and if it um, breaks away, it can cause a lot of harm. So what I'm going to do is just try the legal framework, because here it is very clear who is responsible. There are no ifs and buts. Hello. Okay. Next slide, please. Next slide. Clips into legal obligations. So I forgot to tell. This is 10:30 in Sydney, so it's close to midnight. So I'm a little bit rusty. So this is not a legal advice because I'm not a lawyer. So but I have worked with a lot of lawyers acting on dam failures, hydros doesn't work that well, big Sydney Light Rail. So I know how they operate and how they think when things go about to go wrong. In Australia, point 3, dam safety regulators are in most of the states. They are empowered by the law. It's not a voluntary thing. It is they have the legal power. And also, as we got states, we got they all overshadowed by the federal safety emergencies, because dam failure, like Kantala, is a national disaster. It's not some poor villagers happen to live behind a dam. So it's considered as a national disaster here. And point number 4, regulators have immense power. They can order an owner to fix it. An owner has to come by intermediate and long-term plans. If they don't in time, they can fix it and send the bill back to the owner. If the owner doesn't pay it, they can go to jail as well. Next one, please. So then this one is continuation. Dam owners are legally required to follow the regulators' requirements and guidelines in the first instance. So when the regulator write a guideline, that is empowered by the law as well, because the cabinet doesn't write guidelines; they only empower the regulator to write guidelines. So the regulator has experts and they are in-house staff as well. In the absence of a regulator, in general, we have a thing called Australian National Committee on Large Dam Guidelines, are followed by the owners in compliance with common law. Common law, basically, as I said, not a law. Common law is on dams is you can't build a dam and kill people. And not only kill, you have to maintain it so as you don't kill people in the future. And these are in line with work health and safety, WHS. So the ENCOLD is itself is a voluntary. I work in a lot of ENCOLD committees. I don't even get a free lunch. Whereas Sri Lanka, I will put an X-ray. Sri Lankan National Committee on Large Dam, most are government employees, so they are lucky. Number 3, not comply with set of practice designing, operating. I just put decommissioning. So if a dam is bad, you can't just leave the dam and go home. It has to be decommissioned in a proper manner, because dams normally have a lot of residuals of DDT and toxic as well. And all those things can be as violation of criminal law. And also number 4, consultants can't make a quick dollar or rupee and disappear as well. Well, they are liable too. So they had to practice the best practices. Under number 5, under common law, if a consultant comes to know that somebody is building or designing a dam, even its own employee, boss may say, keep your mouth shut because I am paying you, especially with the government. Law say you can't keep quiet. You have to inform the law enforcement agencies. It's very similar. If somebody carrying a knife on the street, I am supposed to tell the police. I think there's a thing called observing a sin itself is a sin. Next one, please. Now this is underpinning most of the risk-based approaches to the safety, as low as reasonably practical, because it's a criteria which wants to make sure that people spend enough money to reduce the risk or eliminate the risk, as well as somebody doesn't force them to spend too much money to to reduce a little bit of risk. So as long as reasonably practicable, it's not. This is not in dams engine. It's in a lot of heavy industry, LNG tanks. I'm currently doing some in Indonesia. They also allow nuclear power plants allow. So many risky one, especially if something fails, the hazard can travel. Dams, nuclear, LNG, they all are high risk facilities. So there are two steps in relate to owners' obligations. Owners determine their legal duty to reduce risk, ALRP under common law. It's very simple. It doesn't. Sri Lanka doesn't have dam safety laws to make sure they maintain their dams properly. I think it's a big excuse. The second one, owners also to determine what, if any, requirements their regulators may have in regards to ALAP. So regulators, as ALAP is very difficult to exact numbers, regulators have their own, around the ALAP principle or the WHX, their own requirements in each state. For example, where I live, New South Wales, we have things called declared dams. That is, if that dam fails in the flood path, if there is at least one person, that's a declared dam. That means it has to have a risk management plan by the owner, and it should have a plan if there are any deficiencies, how they are going to do it. They just can't say, we don't have money. That's a law. And they currently, rather than ALRP principle, something coming commonly so far as is reasonably practical, SFA. It's very similar, but SFA most do common law, put the emphasis back on the owner rather than hiding behind the number. ALAP gives some numbers on the maximum risk permitted, but SFA say no, it's not good enough. You just need to do what you do. You just need to know what you're doing. Next one, please. Next slide. I thought just to elapse legal background, because if audience is not aware of dam safety, they think this is some fairy tales. It is coming from British law. Let's go back. There was a case in 1949, Edwards versus the National Coal Board. The Court of Appeal was called upon to review, the concept and introduce tests as follows. Reasonably practical is a narrower, it's just a narrower term than physically possible. They want law said, the appeal said it needs to be reasonable as well, practically possible as well. They can't ask the sun and the moon. So it just gave a simple thing. You put the quantum of risk on the scale one side and the sacrifice, the money you spend on the other one. If they find risk is insignificant compared with the sacrifices, they say the owner or defendant discharge its obligation. So that's where these things come. Even work health and safety, they just don't want you to spend too much money, but at the same time, they just want to make sure that you take some responsibility as well. What I put highlight is, it says computation must be done. I saw in the Samanala, everybody says, I saw some guy putting a piece of paper into a hole and say, see, the water is connected with the dam. It's not. You had to do computations. It's not Googling and, putting newspaper into a sinkhole and say it's like building sandcastle on the beach. Probably done by preschool. Even I don't think preschool, maybe the toddlers. So this clearly said need to do computation to measure sacrifices and risk. That's what I am going to show in the next, most of my presentation would be. Next one, please. Next one. Now, this is the tolerability development with dams. I said Australia, but it's most of the countries follow the same. So we have common law is there. Then statute law it needs to have an act. So we have both here. making sure that LR principles are being observed by the owners. The Victorian Parliament, that's where Melbourne is, adopted the so far as is reasonably practical that to bring LR, only dams, nuclear power plants, towards general work and health WHS require laws. And then most Australian states follow the same legislation in 2011. These WHS statutes protect both workers and the public and aim at eliminating or reduce risk a safe way, including in most dams. So it's dams coming under all other things like, the factories, aluminum smelters, everything. Just putting more emphasis on rather than numbers on LR. It's just a legal obligations and as well as uniformity. There is number 4. There is a view that health and safety statutes have simply given expression to the common law. As I said, common doctrine of duty of care. It has been there. I think even for King's days, it has been there. 1949 British court case clearly said that's what you had to do. Next one, please. I think I just thought again, I might be wrong. If I don't get offended, just tell me, "Api thamai hondata kare," you don't know what you're just probably on holidays. I grabs here and there. As I hear, there are a few major dam owners with no center governing body. Ad hoc people do various things. If you are tired or bored doing electrical, probably you can be a dams engineer as well. Number 2, people who haven't perhaps walked on the dam crest issue media statements. I saw few on the TV when I was there. It's not a secret. And these are potentially serious consequences on the dam. If someone ever fails, 250 gigaliters water will travel 78 kilometers. I'll show a with the example later at a higher velocity. It carries everything with it. Kantale happened. So someone not any dam it can happen. Only it depends on the risk and how you maintain it. A common excuse, I say we don't have a dam safety act. You don't have to have one. You got the common law. Why police issue fines for not having lights on your car at night because it's not your safety, somebody else's safety. So if you own the car, you have to have lights, not the policeman putting the lights for you. So I said it's very keen. You have duty of care not to kill people or injure people, and so not to if you don't know the subject, not to do media talk on dam safety because you are liable. If you do electrical non-dam engine, no experience, said something it's safe, we can run the mini hydro, whatever it is, you are giving a false sense of security to the people living downstream. False sense of security is a criminal offense. So incredible jurisdictions, such will attract, as I said, jail time. It's not most countries, credible countries, even mining companies used to say, "Oh, tailing dam is just a dump." No, they take tailings very seriously after what happened in Brazil about 10 years ago. Next one, please. Next one. Something happened. Hello?
There's a small technical error here, Nihal. We are going to reshare the presentation.
Okay, no worries.
Next one. Is this the one the slide you want?
Yeah, let's go to the next one now. Next one. Next slide, please. Okay, this is the key one on accountability. So please listen carefully. Now, as I understand it, again, Sri Lankan National Committee on Large Dam has members appointed by default, and some are government employees. So you get paid, and taxpayer pay the bill. As I understand it, chairperson is Director General of Irrigation Department. And number two, there's a disaster management agency directly coming under the president, who may have delegated the role to cabinet ministers because he can't run everything. So hydropower, irrigation, disaster management. So it doesn't need to be Einstein to work it out. Accordingly, in the Sri Lankan context, ultimately the president is responsible and accountable with national disasters. Example, Kantale in 1986, I think 126 people killed as as it was mentioned at the beginning, and imminent failures due to improper management and no ALRP remedial works to reduce risk undertake. Many dams have deficiency, but you have to have a plan. You just can't say we run a mini hydro or something and make some, because there are a lot of people who can get killed. If it fails, dams do fail. And I think that, for example, Samanalva had a defect for last 30 years. Most things are studies only. And recently the water level was apparently down, and that's the best time to fix a dam. Because then if during remedial works and emergency, not much water in the dam is the good way to fix it. So, and last one, delegation of roles will not relieve the president or prime minister of their responsibilities. So on accountability, as I put it very clearly, it stays with the head of the state. Now, what's a national disaster, 10 people or 20? Probably it has to be discussed on the local context, but that's how it is. It's a disaster. Let's go to the next one, please. Now, this is what I thought lacking, so I spend more time. There may be some areas which the general audience may not understand, but I try to make it very, very simple. That's what I spent last. We had a long weekend doing this for Vadra. Okay, next one, please. So tolerability criteria, as I discussed earlier, that we call it dam where the regulator is needed are declared or referable dams. Normally, if it fails, one person is on the inundation, it's a declared dam. Very easy definition. So, and Australia is, so that Australia probably introduced this concept coming from our, Mammoth Snowy hydro project. But now most countries follow the same, Canada, USA. The risk would include both societal and individual. Society is as a society, large group, individual also need to look after itself. So it's both individual and societal. It is based on annualizing annual exceedance probability of failure, F, versus probable loss of life, known as FN curves. I will show them later. Both F and N must be calculated based on comprehensive engineering. It has to be done properly by experienced engineers. And it should consider all modes of failure. That's not just a sinkhole, everything, hydrology, mechanical, electrical, if you got gates reliability, everything. Next one, please. Next slide. Yeah. So this is how typical FN curve looks like. Always you are required to stay in that blue area. Again, as just because you manage to stay just below that separation line, it's not good enough, as the judge said. As low as reasonably practicable, SFA, IRP, so far as is reasonably practical. So they had to do the numbers. Do I save 10 people by spending another 100 million rupees? So I'm just below the line. So I am safe. No, you are not safe. So it has to be put on the scale and measure. I am not doing it. Judge will do it. Still, as far applies, spend money as a reduce the risk. So just because you are below the line doesn't mean you are off the hook. Next one, please. Now I just showed successful application of LR principles here in the inset. Every dam project upgrade how small the dam is, that has to be done. So Canning Dam upgrade in Western Australia is one of had the largest ground anchors in the world. Each cable carrying 2,500 ton load. I think I did the presentation about 9 months ago. That's the first in Australia to have a comprehensive risk assessment to justify remedial works. When nearly 100,000 people are exposed should they fail. There's a paper I co-authored in 2001 and co. So what is on the looking at the screen on your right at the top is dam is unsafe as above that line. So we did remedial works to come below the line. And again, this is about 30 years old. This curve has been revised few times. So it's not, we just put 10 cables doing some sliding factor of safety, which can be done by a fifth grade student from a good school, but that's not dam. You need to look at all the failure modes and where your risk profile is. Next one, please. So any dam need to have a consequent hazards category. I don't know about the Sri Lankan context. I doubt they have. Maybe somebody told it's extreme, so they adapt that. So it's in simple term, dam is a hazard. So we need to know what are the consequences should it fail. More and main criteria: how many people live in downstream, not how much hydropower you make, not how much profit margin you make, not whether you own by the government or government utility supported by your friends. Need people who would be affected most are the people living. People need to live first before they eat. And number two, please don't assume that our dam will not fail because it got higher factor of safety. Any structure can fail. It's a probability of failure because in dam engineering, a lot of unidentified deficiencies. For many dams, we find deficiency in the dam or foundation when it leaks after it is impounded. So to reduce that risk, you have to do more geotech investigation or grouting and see and have redundancy. If it fails, what we go? That's what many dams have filter. If the clay core fractures, filter is going to stop it. So filter is basically there are a lot of dams without filters constructed 100 years ago. Still there, probably Giritale and other dams. They don't have filters, but nowadays you need more risk evasion. That's why we got any new dam nowadays more than 6 meter high, mandatory here. You have to have a filter. And three, we had to identify two things as said, FNA, probability of failure versus probable loss of life, potential loss of life, predicted loss of life. People, just use that term. Is that how many people can get killed? That's what is in simple terms. Now I just put within bracket, failure of a dam is a dam breach, not a slow failure or not some seepage appearing on downstream. Dam needs to leak as well. If a concrete dam doesn't leak, we know it's a problem, uplift pressure on the foundation. But on the dam failure is the breach of the dam, nothing else. Dam settlement, not a failure. If it's settled below the full supply level or full supply level plus the wave height, yes, that's a failure. Next one, please. Consequent hazard categories. Now I just put it here. Yeah, so basically, irrespective of the factor of safety or how thick your concrete, how flat are your slopes, you have to have a consequent assessment. Should it fail? Then number two, depending on the determined consequence, in most credible jurisdictions, we have categorization from low to extreme. Low means it doesn't have any population at risk should it fail. But there are business and environmental factors too, but main criteria is population at risk or potential loss of life. So as I said, in this case, old rule there's a 15 meters a high dam and large dam, high grade. Well, it's those days are gone now. Even a 6 meter high dam can be extreme hazard dam, while 50 meter is not. So I'm involved with some light trails in Sydney. 6 meter high dam became a extreme hazard dam because should it fail, 94 people can lose their lives. But if you got a 50 meter high in the bush somewhere, probably hardly anybody is a farm dam. So it's a low hazard category. Number four, risk is probability of failure time consequences. So if there are larger people, big population downstream, and probability of failure is one. When you look at the risk is higher. Other way around, few people downstream, higher risk, it become risk, higher probability of failure, it becomes a high risk dam. In case of a dam, a failure is always a dam breach, not water coming through a sinkhole or a spring. Next one, please. Next one. Yeah. So ANCOL was, as I said, first to include this principle, and it's in most of the standards now, and most of the countries follow that. Then there are declared dams in legal framework, as I said before. This means that the government would like to know how declared dams are managed with regular audits undertaken by the regulator. So owner has to produce reports and they will be independently audited by the regulator. If, as I said, if the owner doesn't do, regulator will do with the government money and pass the bill to the owner. Next one, please. Consequent hazard. Okay, this is one how. So we calculate population at risk. That means all people who would be directly exposed to the flood waters, assuming they took no action to evacuate. They basically stay put, they don't run away. Basically, population at risk of getting wet feet. Should the dam fail, water goes somewhere. If they get wet feet, they are counted in the population at risk. Then definition of wet feet or inundated, it varies from country. Australia, we got 0.3. Anything greater than 0.3, people there, we count them under PAR. New Zealand, 0.15, probably they are scared of water. And Philippines, not 0.5. When I asked Filipinos, they said we are used to water. So this is the table I got from ANCOL guidelines. So you can see population at risk, less than 1%. Severity of damage, we assume, not many factories or building, low. But if you got greater than 1,000, it is extreme. So eyes closed, things like summer level, we say extreme, nothing more extreme than extreme. They're coming under the nuclear power plant. The categorization very similar to extreme. So that put a lot of emphasis on the owner to maintain and know what you are doing because it's extreme hazard. Next one, please. Now, as I said, dam break. How do you determine population at risk? You do a dam break. And it has to be done for sunny day. So all sunny, suddenly the dam break. Kantali, as the person who introduced it, it fails on a sunny day. So people don't expect rainy day, at least they will stay inside. Sunny day, bingo, it goes. And also flood failures. During flood, you can get overtop or high water levels can break it. Can also use screening methods or software, such as DOS dam break, Mike 21, TU flow, HECRAS. There are software there to do dam break. Dam breach dimension, how much, what's the opening on the dam, has to be done by a dam or geotechnical engineer, not somebody in Croatia. Or I saw some report in Sri Lanka, some Croatia. It's nothing against Croatia, but you have to base it on your own calcs, local. If it is silty sand, they erode within minutes. DBA gives dam break hydrographs along the valley, and depth, velocity, and the travel time. Travel time is important at night. We don't know until water probably coming to our doorsteps. And location, and normally, as I said, location with dam break wave travel. If dam fails, how it comes to your doorstep greater than 3 years. They assume it's people will evacuate themselves, not counted. Next one, please. Next one. Now, dam break analysis. As I said, sunny day, SDC. This simulates a sudden breach of a dam in a situation such as seismic event, internal erosion, known as piping, except Kantala is a piping where suddenly the dam breached through a hole initially formed on downstream, and probably foundation failure due to solution cavities. For example, like Samanala, they all coming under sunny day. It doesn't have to rain for that to breach. That's what we call sunny day. Then flood failure is like mostly it happens with either spillways inadequate hydraulically or structurally, and also the dam will be overtopped. Oroville Dam in USA, I think about 4 years ago, they had to evacuate 300,000 people because the spillway slept lift off. So those are called flood-induced failure. Now, when it comes to flood, we use incremental, which need to be fair, with and without dam break, because without dam break, natural floods people already has gone to higher ground. So we take the difference. So this assessment is very complex with many implications to the owner. Low to extreme, high A to extreme. For extreme, a hydrograph is probable maximum flood, nothing higher than probable maximum flood. If it is in that table high B, probably, I think 100,000 years flood. If it is low, they don't care about the flood. It can get washed if they want daily or weekly. Next one, please. Next one. Okay. Now I put just for project I was involved in Philippines, 110 meter high near Manila. It's an embankment dam with a height of 90 meters, I think 110, and a storage capacity of 150 gigaliters. It's reasonably big. Many lives would be exposed, I didn't say lost, exposed when it fails, probably inundating suburbs around Greater Metro Manila. The failure scenarios shown in the next few slides are piping. Sunny day, it fails. And the number 4, the breach dimensions, which we calculated, are 65 meter wide at the bottom with a 1:1 slope going up. So it's a big opening. And the breach time formation is 1.2 hours, 72 minutes. So when it starts breaking, it doesn't take much time to break. 1.2 warning time, I think probably 30% of the people will get killed who are on the floodplain. And in this case, total inundation is 90 square kilometers, or 10 by 9 kilometers. So I think it's about 70 kilometers long in that case, 2 kilometer wide, 1.5 kilometer wide. Next one, please. I just want to show the consequence. Now this is a hydrograph. There's a flow versus time at different locations. You can see close to the dam. I think this is about 1 kilometer downstream of the dam. The peak flow is 30,000 cubic meters. Cumex, 37,000 cumex is huge. I don't know, Badra would know. I think some of the DSA and like inflow is 1,000 cumex. This one going out is 30,000 cumex. So 30,000 is huge. As it travels down, the peak reduces, but the duration increase, because all the water in the dam, that 90 it has to go through the floodplain until it enter the sea or the river. Next one, please. This is in Philippines, not in Western countries or anything. So Philippines probably do better than us compared with that country was not doing worse than us 50 years ago. So they are catching up. Probably Sri Lanka is falling behind. Dam break inundation. This is I just got a shot from the report. So maximum depth 30 meters approximately. 30 meters about I think 12-story building. Next one, please. Next slide. Dam break severity. This is how severity is a product of depth versus velocity. They both have a detrimental effect on people. There are some cutoff points. So we based in the severity D and V. So you can see that the red area is most probably people have less chance of surviving. Next one, please. Next one. Next slide. Yeah. Now, once we do the population at risk, that means they took no action to evacuate themselves. We know, say, 30,000 people on the floodplain. Then we had to look how many lives can be lost because some people can run away, some people climb onto the trees. So it's how human behavior. There are few methods in the world. Most popular, Graham, 1990, is coming from United States Bureau of Reclamation. That's what used in most credible jurisdictions to estimate population at risk to probable loss of life. As I can see, bottom one, DYV greater than 15. That slide I showed, fatal rate is 0.75. So 100 people are in the PAR, 75 will die. So that's how it is calculated, probable loss of life. That is needed for that LR principles. So in each zone, what we do, probable loss of life is fatal rate times the PAR, and then sum them all up to get the N value on the risk base. So you know, if it fails, sunny day, probable loss of life is 900 people. Next one, please. There are also, rather than Graham method is complicated. I don't do those things. I get people to do it. Then this decay, he proposed a very simple formula. This can be used just to, if you do a screen level, go by helicopter or something, how many people living in this, on the valley, this one give a quick way to calculate the probable loss of life. It clearly shows the warning time has a big impact on the reduction in the probable loss of life. Next one, please. Okay, I just give an example on how to calculate the results of it. This is, I think, 43 meter high dam. I reviewed about 3 years ago. Sunny day, we got population at risk. It's in a sort of the less populated part of New Zealand. Population at risk 337. Probable loss of life 170. 30% of the people will die or would die. Flood failure, population at risk is 455, but PLL is 71 because there is some warning time, only 12%. So always higher fatality percentage is on a sunny day. So it's wrong to say on rainy days it's going to fail. Most likely improperly managed dams, no dam safe review, no inundation mapping, owners business oriented, they would fail in piping. Worldwide, dams which fail within 5 years, 90% fail due to piping. So someone level showed a deficiency, I think, immediate or during filling. So that's critical. That's a typical case with most of the dams have foundation or abutments or dam deficiencies. Next one, please. So this one, dam safety risk engineering studies. I won't go into detail on that one because each one will take at least a week. Failure mode analysis and risk assessment, just to give you the process. So, you know, the audience can realize, you know, how things are and where they are. Next one. Comprehensive dam safety report. That is mandatory here, 10 to 15 years or after a major event. When I said here, don't say he's telling from Australia what to do. Many countries around the Asian region, India, now got the system developed last 5 years. That's how it is, because they want to see standards change, dam behavior changes, better data on hydrology and seismic. So that has to be done in 10 to 15 years. Now, most of the states here is mandated. There's no excuse. But DSR is basically redoing all the design calculations. You don't take the original design report and photocopy or what you call this PDF and write a one page or cover and say it looks okay and get the money and disappear. As a consultant, you had to do all the calcs. It's a comprehensive. And here, if it is greater than significant hazard category, the regulator will appoint a 3-member independent review panel. They are independent. They have no friends or buddies of the consultant. And key individual studies are hydrology. Now they say, I didn't put the reference, 20% 35 increase in the peak and the volume of input hydrograph due to climate. Say if you are designing a dam for 100-year design life, climate would change it 100 years. Some people say it's climate change is a myth, but that's how it is. There are science behind it. Seismicity. Earth doesn't know when you are going to do the dam safety, but the better data available from the earthquakes occurred since build the dam, as well as better ground motion prediction equations. Next one, please. DSR cover, I just want to show what it covers. As a minimum, dam inspection report by experts. Again, when I said experts, not your buddies, foundation geology is very important. You need to, as I said, after building a dam, only you know your hydrogeology. So you had to get all that into one document or one model. There are better three-dimensional geology models called Leapfrog. You put boreholes, it does the layering itself. All the geotechnical parameters, because the testing methods have changed. So you had to do redo. Hydrology and reservoir routing, spillway hydraulics, static and dynamic slope stability, dams and abutments, M&E, mechanical, electrical. If you've got gated structures, that's very critical. If gates don't work, dam is going to overtop. Structural assessment of all elements. Internal erosion, I highlighted. You got piping. People think piping is, they use Lane's formula. Lane's formula is discredited a long time ago. And then recommendations for investigation and remedial works. Will not be discussing these. These are particular subjects, but I just want to show what the DSR should cover. Next one, please. Then failure modes. Dam can fail in different modes: slope stability, piping, gate failures. So it has to cover all the failure modes. So traditional deterministic calculation are not enough on their own in risk assessment. Need probabilistic assessment based on the engineering calculation. So if you know a factor of safety calculate 1.5, it's a good feeling. It got a low probability of failure, probably 10 to the -4. I'll show you example later. For why I said risk need to be considered. These things are not being taught at unis because they all do angle of friction, calculate factor of safety 1.5. If they do that, they get A double plus in the uni exam. But still, so calculate factor of safety 1.5, still there's a chance that slope can fail. Of course, low chance. On the opposite, if factor of safety less than, say, 1, with the 0.8, it may not even fail. That is because of uncertainty on the parameters and the hydrogeology. That's what the dam engineering now more towards do calculation and then do the risk. Next one, please. I just want to show uncertain friction angle. When you do a concrete gravity dam, somebody give you, a geologist give you the mean friction angle, they always do, that's traditional. As shown here, it varies. So there's a probability that angle of friction, there's a probability, I think 0.1, the angle of friction can be half of the mean. So that shows the angle of friction. In this one, standard deviation is 0.1. So things do change. So sometimes people call sensitivities, but nowadays called risk-based. This all has to be considered. Next one. Yeah, this one I said. Then overall failure modes. You got a dam, no point in saying, oh, angle of friction uncertainty. This one, you need to look at the full spectrum. That's what the risk base. Now here it shows in a gravity dam the difference between the applied as a resisting force. That's a shear strength at the bottom. When difference is less negative, dam is failing. Now this thing I did long, about 1991, I think. We had great gate reliability, the flood uncertainty, seismic, geotech, all that, put it to one formula or package and do Monte Carlo simulation. Monte Carlo is a mathematical model. Even banks do their share market based on Monte Carlo. So it does millions of scenarios and give this curve. So this curve shows that dam has a probability of failure 0.0008 at 0.08%. So although it got a good calculator factor of say, it's still got a probability of failure. Next one, please. List of failure modes in the dam. I just put few you need to consider. It's not a sinkhole or something exists in dams. Dam overtopping, you need to look your hydrology. Then dam and abutment stability. Abutments are the ones most probably because people forget about the abutment. They get carried away with the deeper section, which is the dam. Spillway crest stability, spillway chute uplift, seismic behavior, reservoir rim stability. If the reservoir upstream fails, sometimes it can create a wave and overtop the dam. I think it happened in Italy about 50 years ago, killing 300 people. Or it can come and block your intake tower. Then seismic liquefaction, basically the soil is turning into a soup. It doesn't have strength. Outlet tunnel collapse and erodibility of unlined spillways. Filter compatibility and crest designs. Filter compatibility is basically piping through the dam and foundation. All has to be potential failure modes. If they are not very dominant, has to be considered, but then discounted by experts, panel of experts, not one person saying that's how they did in Pakistan or Croatia. So as I said, double asterisk, piping receives attention in most of the existing dams throughout the world. And probably, as I said, you have one with solution cavities. It's a piping issue, I believe. Next one, please. As I said, one reassess geotech. In this one, Churchman Brook Dam in Western Australia, built in 1927 to major upgrade 2000. We took all the geotech, plot them on this P-Q- and did everything. This has old results, new results, everything to get this design proper. Not some university professor said the angle of friction is 33. That's not dam safety engineering. Next one, please. Yeah, again, stability of the concrete face rockfill dam. They are supposed to be very robust, but this known to have defects in the foundation. So we did slope stability. I just want to put it as an example. Next one, please. Now, seismicity, as I said, better prediction models, new earthquakes. So there has to be updated by the seismologist, not the dams engineer, and then use it for your seismic assessment. In Sri Lanka, I think it's still they are doing for 0.1 G. It's like a medicine for all kio. So Kokatattaila, but those days have gone. Next one, please. reassess filters and internal erosion or within bracket piping. Most dams and abutments can be deficient because we know real hydrology after impoundment only, especially old ones. Then solution, as I said, solution cavity in karstic limestone with sinkholes and springs have similar potential failure mechanisms. Similar. This the diagram below showed it. Then just because water springs on the same downstream, it is not a failure. Dam needs to breach our failure criteria. So you have to work through all the inventories. I'll show later. It's not, you know. So piping needs three scenarios, five. One is initiation event like earthquake or higher water level or known defect. Then continuation, it result to a cavity or piping. Then progress, it downstream to upstream. So it start downstream, coming upstream. And that's probably what happened with the clay field done on your Samanala where Japanese, they all underpin downstream after some time. Then progression, then intervention. Can we intervene? It happens. Most unlikely. How do you intervene? Can't put the finger and close I think a boy in Netherlands some years back put the finger and close the piping from progressing. And then breach. So all that has to be considered to determine the risk of failure. From initiation even to the breach, it's a complex calculation or determination involving experts. Next one, please. I thought just so my experience or explore. I'm not a geologist or a geochemist, as it received your TV news. But I have worked on many piping issues in America and Iran. Iran got a lot of limestone issues. So you need to, as I said, previous one, need full breaching, full scenario. Where is the water coming? Where is going? Is it going to breach the dam? And one thing need to know, solution feature is a pressurized system. It's a tube, water coming like a tunnel. So it can blow up anytime, anywhere. It's like a balloon. Where is the weakest, it relieves all the pressure. Relief, not here, pressure. In your case of Samala, 275 gigaliters. And especially with fluctuating water tables, they are very sensitive to karstic limestone, to changing water level, oxygen and water. And again, post-earthquake, something weaker. Earthquake doesn't need to be big. Smaller one will trigger it. So as I said, treat with respect and also don't poke the tire, for fun. Those are pressurized systems. This I got from a project I worked few back in North America. It says sinkhole on a karstic limestone. Next one. Typical piping assessment, as I said, those five this is the inventory. Initiation, all these things had to be done to do the final failure mode. Key input, engineering assessment. We can't just put them on the internet or what do you be a failure probably 0.5, 0.3. We need to benchmark our brain with calculations. We need to know a factor of safety 1.5. Our experience failure probability will be 0.001. That's how the inventory works. As I said, it should be done by opinion of experienced people, not by Googling. Next one, please. Filter stability. Again, as I go, filter is very, very serious. Filter is the one ultimately going to stop piping happening in any dam. So you need to look at all filters. Sometime workmanship, people take money and when they put wrong sand or some sand breakdown and some sand cemented. Cement and sand is not a filter. Filter is supposed to, when the soil shears off, sand should follow. If it is cemented, it doesn't. So it allows the piping to happen. So people have to get the old reports, construction report, plot them, and take samples and do them. That's part of the dam safety report. Next one, please. Estimation of conditional and total failure probability. That's the. I just it's still yeah. Let's put the next one, please. Yeah. I just want to give the complete picture. What are they? Conditional probabilities given initiation event. What is a failure probability. For example, water level in the storage went up 5 meters. What is the failure probability of the slope now? It's called fragility curves. That's a key input to the risk. Then initiating events, usually reservoir water level and the seismic acceleration. So P, what you call peak ground acceleration. These are annual exceedance probability. And this is usually known as system response. They are to be partitioned. I will show you why it is. Then Fourier probability, system response, that's initiating event probability, say 10, 10 1 in 10,000 year flood, multiplied by the, what's the failure probability? Next one, please. Yeah. So this one, I just put, there are simple ways to do that too, where some people get scared when they look at CAU entries, and some people get attracted because they know they can do a lot of black magic. In dam safety assessment, usually event trees type simulations is the norm, acceptable in other countries as well, North American. Traditionally, calculate factor of safety can be directly converted to failure probability without doing sophisticated simulation like even Monte Carlo. At screen level, a statistical method as shown below for slope safety. So what this curve is, they have look at calculate factor of safety, and if those things fail, they put statistical. So if a dam has factor of safety 1.5, probability of failure is 1 divided by 10,000, so 10 to the minus 4. That's the one quick way to do it, but it doesn't work. Statistics doesn't take the known defects, unusual cases. And in the case of piping, of course, we got University of New South Wales method as well. Okay, next one, please.
Let me have a disturb for a moment. Shall we go a little bit faster?
Okay, yeah, okay. Let's go quickly. How many minutes we go now? Yeah, let's go quickly. Yeah, next one. I'm going faster. You're okay, next one. Yeah, system response curve. Hydro geologists would know. This is the, you do reservoir routing, water at full supply, and the water level versus probability of annual exceedance probability. Next one, please. Similar with peak ground acceleration given by a seismologist, peak ground acceleration and annual exceedance probability, normally known as probabilistic seismic asset assessment. Next one, please. Condition of failure. Again, as I said, given event, what's the failure probability? That complex event trees come to this thing. So given water level, that's the probability of failure. Next one, please. Okay, similar to earthquake, given acceleration, that's the probability of failure. Next one. So Tauber probability is the product of this one. This pie chart shows different failure mode. What's the percentage? In this case, the blue one is this dam is dam overtopping is the carrying the highest risk. So if you got money, that's what you need to hit first. Next one, please. Okay, all these things end up in this curve. So in this can see all the failure modes stay below the separate line of separation, but still AR layer P say owner, you need to spend some and see whether you can bring them lower, putting on that scale. Next one, please. Okay, next one. Yeah, this is a thing. When you spend money, there's a rule called gross disproportion rule test. That means how much money you spend to save a statistical life. So how you put the dilemma is, how do you put a monetary value to a kid's father, mom, dad, or sibling? You know, I think your father was $400,000, so 10,000 rupees. Next one, please. calculation of, you had to calculate here, or most standards now, cost to save statistical life. That's the formula. It got all the economics and the failure probability, reduction in the risk, all that. We can calculate how much money I had to spend on this project to save life. Next one, please. Yeah, this I put example. This is calculate for various failure scenarios in Australian dam. You can see on the right, is spending anything more than $200 million, $200 million to, yeah, $200 million to save a life is considered as a poor, not poor justification. Next one, please. Next one. Yeah, so this is very quickly, I want to wrap up with the investigation and remedial works. You need to get all the remedial works for all the dams in the portfolio and then rank them, which is the most critical one. So that for the whole, all the dams in the portfolio, not one dam. And please remember, dam safety, incredible jurisdiction, there is law which says you can't increase the existing risk when you're doing remedial works. That's what I thought. Something like summer level, when the water level is low, is the best chance to do any remedial works or even do investigation, because if it fails, you haven't compromised the risk. So I believe, I think Sri Lanka, they did dam safety upgrade 10 years ago. Hopefully they did, which should be done first based on the portfolio. I'm still surprised how that one missed summer level. Next one, please. Be careful with knee-jerk remedial work. So as I said, you can't just take one solution and put it everywhere, like a toe drain. It works for some dam, it doesn't work for other dams. And then grouting, if you grout the foundation, probably you may end up grouting the filters on the dam. That's the last thing you want to do. Sometime 10 years ago, it happens on a dam here. Grouting, not knowing where the foundation hydrology, but if you plug somewhere a water path, it gets pressurized. That's what you had to be very careful. Grouting, caustic, limestone. Permanent lowering of the water level. We think we reduce the risk, but had to be very careful. When you lower the water level, you are drying the crest. So desiccation, cracking. At higher water level, it can cause piping. That's what we now put filters around the world to the top of the dam. All days it only up to the full supply level. Most of the dams pipe under floods when the water level above that line. So one is, either live with the devil or decommission. Next one, please. Okay, last one. Badra would be happy. So decision on remedial works to existing dam is complex. ALRP, as low as reasonable practice principles, would dictate under common law. You don't have to have a Dam Safety Act. Accountability for a natural disaster always with the president. He runs the country. Professionals can be charged under criminal officers for lack of duty of care. And any remedial works should be risk-based with thorough engineering assessment. Existing risk profile cannot be compromised by improper remedial works undertaken without thorough study. So if you compromise the existing risk during remedial works or after, you need to answer to somebody. Anyway, thanks, guys. Just too tired. Thanks, Badra. That's all.
Thank you, Nehal. Sorry for pressurizing you for going to the past track. Actually, I feel a bit guilty about that, but of course.
Yeah, let's go.
Yeah. Anyway, your keyword is risk reduction. So really, this is an eye opener to most of the audience here. So thank you very much for elaborating the legal implications during your first part of the presentation, you clearly explained in other countries what are the legal background that the dam engineers have to face. So, especially the negligence of duties and things like that. So, in recent, I called International Commission of Large Dams Congress. I participated. They were not talking about the dam breach actually. Now they are talking about the people who are at risk even in drowning. So for that, they claim that the dam engineers are responsible. So that is the level the other countries have gone. So that is why we are a bit worried about this. So we saw that there are comments and questions in the chat box. I will request the audience again to post your comments, questions in the chat box before we open it to the at the Q&A session. Thank you very much, Nihal. It may be really hard task for you during the day,
That's
night
okay.
time.
That's okay.
Yeah.
We go.
Thank you. So, as mentioned at the beginning, we invited two Sri Lankan veteran engineers who made the effort to introduce the dam safety approaches in Sri Lanka, in Sri Lankan systems. The first discussant will be Engineer Aruppala. He's known to many of the dam engineers in Sri Lanka. He's a chartered civil engineer with experience over 35 years in dam sector. He's the former director of major dams in Mahavali Authority and has been involved in construction, supervision of different kind of dams, tunnels and associated structures, and involved in instrumentation analysis, trend observations, and upgrading the dam monitoring instruments in the existing dams. He's a member of dam inspection review team of World Bank assisted projects. He's currently a dam safety consultant to the World Bank, working in a few countries, and also a council member of the Sri Lanka National Committee of Large Dams, in which Nihal mentioned several times. May I invite Engineer Aruppala to share his views based on his Sri Lankan experience as well as with the international community, please.
Good evening. Thank you very much, Nihal, for the presentation, which really helped to open eyes of the people, not only the commoners, but also the engineers and the other responsible people who are following this dam.
Can't hear.
Aruppala, it is not clear. Can you have your mic more clear?
Yeah, can you hear me now?
Yeah, now it's okay.
Yeah, because that I must first thank to Dr. Nihal for that is a very informative presentation, which managed to open the eyes of the people who is responsible, not only the engineers, but the people that who are taking the decisions on the safety of the dams. And I think that your presentation is very nicely complying with these high-call regulations, which really insisted in many their bulletins about I think bulletin 29, it very clearly emphasized about the risk on the third parties of operating the dams. The dam owner has a huge responsibility to have a safe operation and safety of the people who are living downstream. This very specifically mentioned in the bulletin 29, as well as the bulletin 59. There are also that about the dam safety guidelines, which very precisely inform to the dam owners as well as the dam operators about the importance of having the dam safety guidelines. And similar about the dam monitoring, bulletin 60 also that they emphasize about the dam monitoring. And I think that some of the dams in the Mahavali, like the large dams, that all they have covered with the emergency action plans, risk analysis in the years 2011 to 2015 with the help of the expert consultants. and they prepared the emergency action plan and the risk analysis and risk analysis are still active, especially the dams controlled under the Mahavali Authority major dams. And we are updating these things and we are having some discussion with the disaster management division also to the level but the maximum but possible with the authorities what the Mahavali Authority dam division has. But I think my worry is also about the safety of the Samalurava Dam and the right bank. Still, I think to my understanding, there is no proper risk analysis has been done for the Samalurava Dam, following the regulations, what you said, the last principles or other, whatever the recommended conditions, to make the people aware about the risk what the people living in the downstream are facing with, and ultimately the government will be responsible for this. Especially the dam owners has to carry this message to the people where that you are responsible for this, to have a proper kind of emergency action plan for this. And I think we must emphasize about to have a real time the dam monitoring and the right back monitoring system for us to prepare about the results and where immediately the dam would start to fail at risk certain times, maybe the right time for the dam. And then we can inform the downstream people to evacuate or to take some actions, how to prevent that their lives, loss of lives from the huge flood which would flow through downstream side. I think as a team of engineers, especially the SLN call, I call, and the owners of the dam need to take very stern action without taking much time. First, undoubt to do the repair works, but at the same time have to give the equal priority to have an emergency action plan and the real-time monitoring systems, especially for the right bank, as Dr. Nihal said, also to check the dam reliability of the spillway gates, bottom outlets, and other instrumentation data periodically should be inspected by an independent team of the engineers to ensure whether the dam operations and the dam monitorings are following the updated the regulations, and to have a proper monitoring systems following the recommendations of the ICOL regulations. So this is what that I want to add, and I think this should be a very good stage to start with the forgotten risk of the Samalurava right bank. Thank you very much.
Thank you very much, Mr. Arupala. I think you have given a very good suggestion on how to proceed with the current situation, the critical issue what we are talking, even though we are not talking directly today on Samalurava, but with your basic background on dam safety and also with Samalurava, you have suggested a very good approach to tackle how to tackle it. Thank you so much. We will continue this discussion further. And within the short time, we know that you can't have the given time, actually you have given only 5 minutes time for both of you. So with that comment, may I invite Engineer Lalit Dialis, who is in the audience. Engineer Lalit Dialis also, there is no need to introduce Engineer Alice to the audience in Sri Lanka, especially on water sector. He retired from the government service as the secretary to the Ministry of Transport, and also he was the additional secretary to the Ministry of Irrigation. While working in the irrigation ministry in different capacities, he spearheaded many policy changes especially on preparation of a Dam Safety Regulation Act, was a brainchild of him, and submitted the same to the government. That is one significant event he made. Unfortunately, with the changes of the top positions in the ministry, this initiative did not see the light of the day. Currently, Engineer Alvis is the chairperson of Ceylon Transport Board, the first engineer who was appointed to this position, this prestigious position. Lalit, over to you.
Yeah, thank you, madam. Very good evening to you all. First of all, I must thank to the organizing committee for inviting me to attend this event, because as a dam lover, as well as the expert who work for the water resource sector in Sri Lanka, I had to accept this the invitation to share my experiences. Also, thanks to Dr. Neha Vitarna, because you made the very deliberate and informative the presentations in your presentation. So, I actually, what I want is to the focus on the necessity of having a regulator in the country. So this was we initiated in actually what was happened in 2016 and 2017. We tried to invite all the stakeholder agencies to get together and give a pressure to the government to establish the Dam Safety Council or Dam Safety, the Regulation Authority in Sri Lanka. With the experiences we gained after the dam breach at Kantale, as well as the other consequences happened with the major dams in Sri Lanka. So I must thank to the Svenfold as well as the Irrigation Department and the Mahali Authority of Sri Lanka. With the pressure given to the policymakers, it was able to rehabilitate to upgrade the most of the large dams under the dam safety and water resource planning project funded by the World Bank. During that time, as we were the senior engineers in the irrigation department and the Mahali engineers, including Mr. Aruppala, we were able to discuss several matters pertaining to the dam safety aspects in Sri Lanka. And finally, when I hold the post as the additional secretary to the Ministry of Irrigation and Water Resource Management, I wrote a concept paper to the minister to convince him to put a cabinet paper and get the approval for establishing the dam safety, the regulating authority in Sri Lanka as a dam safety the council. So the most of the key stakeholders were supported for that proposal, including Mahaweli, the National Water Supply and Drainage Board, Ceylon Electricity Board, even some the provincial councils that directly manage the large dams, especially north and east. So they were able to give their the idea for establishing or the formation of the Dam Safety Council. The concept was developed by the senior engineers who worked in the irrigation department, including Mrs. Bhadra Kamaladasa and Mr. Dhammika Veerappa. Both the Director Generals of Irrigation and all held the post as chairman for the Svenfold also. Now the document is there. The cabinet approval is there. But the problem is we need to have the champion leaders to fight with especially the administrators and the policymakers and the politicians. My experience, what I gained is the convincing the politicians is very easy, because they are when we explain the matters for them, they will understand, right? So because during that time the honorable Gamini Vijay Muniswasa was the minister, and myself and the Mr. Ratnayaka, then secretary, we were able to convince him why we need to have the dam safety. The council in Sri Lanka, he accepted, he instructed us to prepare a cabinet paper. We put the cabinet paper, get the approval, then we formed the expert group, including 2-3 consultants to prepare the draft document. what I did was I did only the management part of the job actually. As the policy maker, in the ministry as additional secretary, I did that part, but it was not continued after I left the ministry. So then the next successors should take this baton and run the relay. So now it is very easier to go back to the level where we stopped actually, because the how we I must tell you to how we can get the support from the politicians, because there are 3-4 platforms we can talk. There is a committee on public petitions in the parliament. Anybody can write to the public petitions committee, then they will take up the matter at the parliament. The committee is there. It is chaired by the prime minister. I did it for the transport sector actually, right? Because we need to have the vehicle regulation to the country. What I did was I wrote to the Committee of Public Petitions. They took up the matter and they instructed to prepare a damn safe vehicle regulation policies to the country. So the other thing is now again the oversight committee for each and every sector is again activated. So what we can do actually, we can the right to the oversight committee of the irrigation sector or the water resource sector, chaired by the senior ministers. So we can, and the other parliamentarians, we can talk this matter at there. Then third is, as Dr. Nihal correctly said, the disaster management center is there. It's under the president. So we can talk with the disaster management center, the Director General of the Disaster Management Center, and submit the joint proposal to His Excellency. Then the other thing is, we can directly write to the Secretary to the President, because as we are professionals, we need not to be in silent with this, because this is very critical subject. The every aspect, Dr. Vitarna, he correctly shows us every aspect how we have to be look, how it affects to not to the socio-economic situation in the country, especially for the life-saving aspects, what we can do as engineers and the expert in this sector. Then, therefore, I kindly request all the engineers who love for this sector, especially our role is to, the engineer's role is to play in every stage to secure the people in the country, right? So this is high time to discuss considering the present situations arise with the summer level issue, because there are the various interests are there. So the most of the people who are living in the southern part of the country, especially in the Kaldota and Udawala area, they are very the leak is there. They are very happy, right? Because they get water for the cultivation. Then the CEB is having the other way, right? While having a leak, if the water is there, they can generate the power. But the risk, anybody still not assess, as Mr. Arupala said, no one has done the risk assessment for the Samanlaya Dam, because even when we were young, the people actually we know that the so many at the time of the water leakage was started. There were a lot of the geologists complained about the geological formation is not fit for the constructing dam. Especially Professor Vitanake from University of Peradeniya, he has written a very good comprehensive report. If the now young engineers can go for the review those literatures, you can understand what they have given to the next generation to do the studies and understand what should do them. So this is the job going to hand, generation to generation. Therefore, though now we are the retired people, we have obligation, or we have some duty to deliver to this society and aware the young engineers not to be in silent, that take the challenge and be a leader and talk with the relevant people. Even to the general public, we can go there, the Calcutta area, and those who will get suffered if the dam breach is there. We can convince the people first, actually. Then it's a social issue for them. Now the people, they don't aware anything about if any dam breach is happened to the Samanla, the people, they want to be. Because in Sri Lanka, what we did and what we are doing is, after the event we take the measures. Before the event we don't take any thing to prevent the event, right? Especially prevent the loss and damage is a very good thing. Even after the tsunami, we were very concerned about the buffer zones in the coastal area. Now everything forget. Now again we construct the hotels and buildings and houses on the coastal area. Now the coast conservation and the coastal resources department can't do anything, right? Because now they are kept quite in silent. The people that do the construction, likewise, no. Therefore, without if anything happened to the Samalaya or any other dam, then after that the eyes will be open, even the politicians as well as the policymakers and the administrators. The matter of this, the problem is to get the ownership of the ruling, actually. Who should be a leader in the council? Either the administrator or any policy maker. In this society, society does not permit us to be a leader in any sector, right? But always I convince to the politicians when I do some discussions, I convince this matter. The reason the case is the general manager railway was not an engineer. To the present minister, I explained this matter. Without having a mechanical engineering knowledge or any engineering knowledge, how the locomotives and how the carriages can be run on this railroad. Only 1,400 kilometers we have, but the trains are not running at the correct time because due to the technical fault in the railway system as well as the technical fault in the locomotives. Now he understood, because I make some changes in the Sri Lanka Transport Board also as an engineer, get the assistance of the other mechanical engineers, actually, who are my friends. I get some advice because I don't know the mechanical part, but I can contact the people. No? Likewise, what we can do is, actually, there are experts who are Sri Lankans living in the other countries, like Dr. Nihal and some other. Earlier we had Mr. Bandula Kayandaraga and another yes, from USA, one. Actually, we had the good opportunities to get their the instruction or the consultations, and especially during the project implementation of dam safety and water resource planning project, this was very popular subject among the engineers. But after the project, again, this was not discussed, not taken up seriously. So thank you for inviting me. What I want to stress again, please talk with the politicians and administrators and as well as other policymakers. And we have access to the talk with the people who, the committees as well as again restart the consultation or the stakeholder consultations workshop with the relevant parties. All the literatures and all the files are there in the ministry. The present officers who are working at the ministry should take the leadership, right? Because the ministry is the ministry to work with the government. So under the subjects, therefore the irrigation and both irrigation and Mahaweli sector senior engineers should take the lead role to convince the importance of dam safety in the country, because I think no any other country in the world more than 1,300 dams in the 65,000 square kilometers of land area. So the density of the dam in the country is very high. Though it is a small dam or the medium or large dams, we have to secure them in safe site. Therefore, thank you very much again. I can participate for any event if you want to go and discuss with the politicians or any other the people in the country. I will attend for any event with you all. Thank you very much.
Thank you.
Thank you, Lalit, for your very impressive, very useful suggestions. I'm sure with your experience, even the current experience, and also we know that you are brave enough to suggest anything to the politicians as well as the administrators. And this is what is continuing at your present station as well. So we hope our officers, current officers who are responsible for this will take this up. And I think we have to go since it is almost Nihal 6:50 time. I don't know what is the time there.
It's 15 minutes past midnight. Any questions? We'll go for another 15 minutes.
Yeah, that's right. There are many questions, but I would like you to take up your questions. I am not going to waste time on repeating the questions. You can see them in the chat box. Can you take up the questions? Or do I have to repeat?
Just yeah, I think it's some are very long.
Right. Okay. Now the first question is actually who is the owner of the Samanala Dam, and the answer is Ceylon Electricity Board. And who are the beneficiaries? That is the mainly the power sector. And what the organizations manage the dam, it is again the Ceylon Electricity Board. And I am trying to understand who will be who will end up in the jail. Okay, I'm not going to answer that.
I think I will tell. Probably it goes on the food chain.
Sorry?
It goes on the food chain. Who look after the dam? Engineers, then the minister, and then I think your president can't go to jail until he lose the election. So those are the people, not anybody else.
Okay. Okay. Our ISL President Dr. Laxer is also here. We can see him. Hopefully he will answer some of the questions here. So, engineer, he has raised the question. Some years ago, a dam safety assessment study was done with foreign consultants. Is anyone aware of the final report of this study? I don't know whether Mr. Aruppala can comment on that. Mr. Aruppala?
Yes. Can you hear me?
Yeah.
Yeah.
Okay. Okay. So then, yes, there are some studies has been done dam safety assessments, and the reports that after the completion for each and individual dams has given to the dam owners. I know the dams belong to the Dam Safety Mahavali Major Dam Division. Individual reports are with them, and they are updating the things. And I think maybe other authorities also, other departments who own the dams may have that reports individually on the dams. I know about the Mahavali Authority dams that we have the reports and that they are updating.
I think, but the issue is not the report. The report should have deficiencies and remedial work. So owners have an obligation to have a plan and do those things. Report.
Yeah, I think,
Anybody can write reports. I write reports, but a report without deficiencies identified and conclusion, and asking owners to give a time frame and how time frame and then monitor it. Otherwise, it will be another holiday for foreign consultants. I like to go on holiday as well.
yeah.
This is a fundamental issue with all your dam safety things. A foreigner comes, write a report, probably local get few foreign study tours, then the report goes somewhere, it disappears. I am surprised how someone ever missed on this dam safety portfolio risk assessment, unless the allocation of the dams were based on the friends. How can someone have ever missed out? Whereas, little I have seen some people came out, we are going to put a ladder on this dam from dam safety. I said, that's not dam safety, that's public safety. Floodlights, that's not dams, that's public safety. You carry a torch, dam won't fail. So somewhere, something is drastically wrong. I don't know where it is. Somewhere drastically wrong.
To my understanding, from the first stage, the consultant have identified some of the critical items which need the rehabilitation, where the risk is high. As you said, the risk factors have been calculated, and how the things has to bring down to the safe zone. From Mahavali Authority side, I know that we have identified the major risk areas, especially spillway, gateway tower, some kind of the dam monitoring, and certain areas and some studies for the dam. And they have done the repair under stage 2, with the stage 2 to bring down the risk, and that they have done the post risk evaluation also, analysis also, where the risk is that is some kind like the semi quantitative risk analysis, where the risk factors has gone down. So with that, to my understanding, to my knowledge, the portfolio Victoria, and these dams has been attended for the repairs recommended by the consultant to the possible low levels. But I'm not sure about the other dams. I know, but the Rajangara Dam also, they have done some rehabilitation work for the spillway gates. And there may be some dams that they have done on the recommendation to bring down the risk levels. But I'm not aware about these other dams. Maybe other dam owners that you can come with us.
As I understand it, someone however doesn't have a inundation mapping. That came up in that webinar when I listened to in Sri Lanka. So how can you operate the 7th largest dam in Sri Lanka, 7th or whatever it is, having known to have a deficiency is not intended in the design, doesn't have inundation mapping. Here we're talking about consultant's report. Something somewhere wrong. You guys need to sort that out.
Yeah, consultants have recommended in 2012 report, the CEB has to start to work with the some kind of the risk analysis. But I'm not sure that you can check with the CEB.
See, 2012 to now is 11 years. A kid enter the primary school, now at the university or somewhere if he's lucky. So that's the time frame we are looking at. Kid go to university.
Yeah, it is that the CEB can reply.
Yeah.
I'm just pointing out, we can have these webinars, all that, but just need to get to the bottom and see what's going on.
Yeah, Nihal, there's a comment by Engineer Malik Mendis saying that when he was the CEO of Lanka Hydraulics, simulation dam breaches in have been done, and they have done Kotmale dam, and he says that according to their study, the Peradeniya will go underwater, including the university, by 3 meters. So that's a comment anyway. So just to complete the comment what we are talking about.
What
Then
dam is it?
Kotmale.
Okay.
Right? Yeah, in the upper reach of Mahaweli.
Okay.
Right. So the next comment is from Dayanta. This is excellent presentation. There is no question about the value of this information, but forgive me for saying this. I feel that we are barking on the wrong tree. All professionals will fully understand the importance of everything discussed, but what will happen after this? Is IEL president prepared to meet the president or prime minister? Okay, let Engineer Laxir is there to answer. I'll go to the next question. Engineer Bandula Kanaragama has noted that in Sri Lanka is yet to do a lot of work in the field of dam safety, including development of dam safety guidelines and pass the Dam Safety Act in the Parliament. He has given a lot of, links to the in later. I have seen later comments as well on the regulation, what Mr. Lalit Dialvis was talking about, the draft regulation that was prepared by the Minister of Irrigation. And the next comment by Engineer KLL Fernando. Do you have dams owned by private parties in Sri Lanka? No. Only all the dams are owned by the government. And again, Mr. KLL Fernando, can we have a discussion of Samanalawa leakage to get the opinion of the experts? Some say grouting the leakage is not advisable. So what are the solutions? Of course, we have organized another presentation on 10th of October to elaborate on what the investigations done so far. Not only the investigations, the remedial measures what were implemented. So you can join that as well, the discussion as well, and then we actually continue this dialogue or discussions further on, especially focusing on the Samanalawa. And then again, Mr. Vandula Kandaragam has noted that is there a dam safety emergency management plan or emergency action plan for Samanalawa Dam incorporating dam break study. So actually there is no one in this audience or in the panel to answer that question directly, but we will post that question to the engineers. Is there anyone in the audience to answer that question from the electricity board? There's a comment by engineer Shavindranath. He has told no one will go to the jail. That is why there is no one taking care to do anything.
Is the jail full? Is it Velikada full or what?
Yeah, that is another reason. Yeah.
As I said, Badra, sorry, if you take that Hungarian example to get punishment after event, you don't have to go to the jail. Not you, people will react. That's how it is.
Okay, and there's another comment by Engineer KLL Fernando and Engineer Kandaragama. You are one of the dam safety engineers with a lot of experience. What are the contributions people like you can offer at this stage? Joining of local experts are all talking and nothing happened. Actually, I must acknowledge Engineer Kandaragama's contribution, even though he's in Australia. Whenever he comes to Sri Lanka, he used to offer his service free of charge. He conducted many training programs to our dam engineers at the site, and also he intervened a lot in framing of the dam safety regulation that is suitable for Sri Lanka. And engineer Siraj Pereira, who is the dam safety regulator in
Melbourne.
Yeah, he also came when he was here in Sri Lanka once. He shared his experience with the dam engineers, especially on introducing of regulations and what will be the how the Sri Lankan should go set upon to frame to submit the proposals to the government. So those are my comments. Any other questions that is from the audience? Are there anyone who is interested in raising the questions? Can you please raise your hand and join? Dr. Lakshri, are you there in the audience?
Probably he ran away after your question.
Okay.
See,
No,
I think let me make a comment on, I'm not going to do that, as, I just give this one and other things, just, awareness. Otherwise, I'm not try to tell what to do or when to do, or you don't need a damn safety guidelines to do this work. That's what I'm getting. Common law is there. And what you need to say, we follow I code and code and do it. I think this, we don't have a damn safety act is a big excuse by the professionals, put it bluntly. We don't have a dam. You don't have a university teaches them, and some countries they say follow I call. That's enshrined in the cabinet, or if not, if you are a owner, common law says maintain it. Nowadays, people Google for cricket. If you Google, you can get easily, American standards or whatever it is. So not doing that, just always we need a damn safety act. Is then as in buying in another 10, 15 years for senior engineers to retire. That's the current situation. I think Bandula would say how much energy he probably wasted. He texted me this morning.
Yeah. Okay, thank you very much, Nihal, for that comment.
Hello, may I raise a question regarding? Hello.
Yeah.
Hello. Regarding actually to avoid such situations where these because if we can consider in the present designs the during the design stage, if we can consider the dam failure simulation and identify those areas downstream and prepare a rescue plan or something at the design stage. I don't know whether in the world what is the situation. Just design a dam and construction. After the post construction and during the maintenance, it happens because if it could have been done in Sri Lanka before, I think that we can easily implement such things, no, without difficulty.
No, before building a dam, even under concept report stage, need to have a dam break and consequence. One is for the safety, determine the extreme, what's the flood you are going to use. Other one, environment impact statements. World Bank nowadays don't put money on hydropower or give a loan unless they see a dam break and the consequences. What they say is, if they give money to hydropower, there is no dam after it breaks. They can't recover the money. Other thing is they don't want to get the blame for killing people with the dodgy dam. So dam design stage, probably 50 years ago it was not there, but now 50 years ago hydrology not done. They said dam crest flood is which can pass 1 in 1,000 year flood. That's all. But we have moved on.
Mhm. During the new designs, actually, what I want to know is there any dam failure simulation to identify all the consequences at the
Yeah,
downstream?
as I said on the dam break, those softwares, they are softwares.
Yeah,
No need to physical models sometimes fail because the
okay,
dynamic dam
that's
break is very
fine.
dynamic. So physical model now I'm doing getting done computation full dynamic. We don't do physical model of the completed
Haven't
spillway
seen that.
crest before building. So they are there. So new dam should not be approved in credible jurisdictions. I don't know in Sri Lanka without those things in place.
Have we
And
done those two like Victoria dams and other things in
probably
place
not
before?
those days, not those days.
Um,
That's what I said. 10 to 15 years, you need to do a dam safety report. Do all the calcs as per current standard A to Z.
yeah, yeah. Yes, thanks. Thank you very much.
No worries.
Victoria now have.
Yeah, now has probably during the design stage. What else? Badra, finish? Finish? Okay, I think we can finish it. What do you want to do? Okay.
Dana, a quick question, if you don't mind. I had to miss part of the discussion, but question I want to ask is, what do you recommend that IESL should do under these circumstances?
What is IESL? IESL stand for Institution of Engineers Sri Lanka.
Sri Lanka, yes, we are
And
supposed.
they should be on the front line.
Exactly. So I wonder whether any of our council members are in the audience.
I think you are getting us involved in politics. Huh?
No, what I want to know is, what is your recommendation? How do we react to this situation?
See, as I said very clearly, duty of care. Now, in simple terms, I can't make a long knife, and give it to somebody without knowing what he or she is going to do. That's illegal. Sri Lanka, everywhere, even Somalia. You need to know when you produce something, what you in person, what's going to do. So if you look at Sri Lankan National Committee on Large Dams, most are government employees funded by the cabinet, all that. So they have a duty of care. I think IESL is a voluntary organization. So as I understand, so probably they are a little bit, they have a moral obligation to act on these ones. But Sri Lankan National Committee on Large Dams directors, they have an obligation to safeguard the things and take the matters with the politicians or whoever it is running the country. IESL is a voluntary organization, and but they have a moral obligation to the people via their membership, and that's what they should be doing. But
yeah, Mr. Singh, yeah, actually, we are continuing this dialogue. We already issued a news release statement to the media on IESL stance on this issue. I don't know whether you have seen it in some news radio channels also, though these were broadcasted. So we are following this up in various fronts. Hopefully we can share the news release
We
issued
have a
by
long way. I'm sure the Water Forum has to take the leadership in this one and push it till we see something satisfactory in place. That's, I think, our moral obligation, like Dr. said, that we can't ignore.
And you have an obligation to inform the law enforcement agencies. And I don't know what's the disaster management agency in Sri Lanka do after a disaster. They have managed to probably after disaster is more money for some people, so they're trying to avoid the disaster. So it just coming, as I said, I can't watch a sin happening without reporting or taking action. Itself is a sin. It's a law in many countries. If so, it's very complex. But I think that somebody need to raise awareness. It's not cost benefit analysis. For example, someone has a mini hydro versus what you call the leakage. People forgot the value of human life. There are people don't like to see. I put 10 lakhs for your father's life. How can you walk into a house and say, "Look, we didn't fix the dam. Sorry, I killed your mom and dad." That's what called moral obligation in simple terms.
Okay, Nihal, I think it's now time for us to
wrap up.
Yeah. So,
There's somebody, some researcher wrote a long one. I asked he or she to send me an email. I think some Senaviratna, I think. Yeah.
Yes, Dr. Nihal, it's me, Dr. Samanthi Senaviratna.
Yeah, please send me an email.
Okay, thank you very much.
Okay, see ya.
Samanthi, sorry, we missed some of the comments because of the technical error here. We have lost most of the comments in our chat box. So, sorry again, I think you can have a direct connection. Please write us again. Then I would like to invite Engineer Janaki Nigastan, our Water Forum Council member, to deliver the vote of thanks.
Lightning event to a close. It is my distinct honor to extend ISL Water Forum heartfelt thanks to all of you for being a part of this important discussion. Today we had the privilege of hearing engineer Dr. Nihal Vitarna, true luminary in the field of dam management and safety, who share these invaluable insights. We owe a special debt of gratitude to Dr. Nihal Vitarna for generous sharing his expertise, which spans over 4 decades, covering dams, geotechnical engineering, structural engineering, seismic assessment, and durability evaluations. His contributions have significantly enriched our understanding of dam safety. I would also like to extend our appreciation to our discussion, Engineer S.R.K. Aruppala and Engineer Lalit Dialvis, physically present here, for their valuable insights and contributions to today's discussion. Acknowledgements are also due to the leadership of the Institute of Engineers, Sri Lanka, ISL. I thank Dr. Kamal Laksiri, the President of ISL, Engineer Neil Abeysekara, the CEO of ISL, and Engineer Kamala Gunawardena, physically present here, Chairperson of the Civil Engineering Sectional Committee, along with the dedicated council members for their support. Also thank to technical team of ISL for their continuous support to make this event possible and run smoothly. A special note of gratitude goes to Engineer Bhadra Kamaladasan, the chairperson of Water Forum ISL, whose guidance and efforts were instrumental in organizing this event shamelessly. We also extend our appreciation to the Water Forum Executive Committee, including Secretary, and the young engineers who played a significant role in organizing this event effectively. Last but not least, we extend our thanks to all the participants who joined with us physically, both in personal and virtually. Thanks a lot for your contribution, your comments, and your suggestions. Your engagement and commitments to the cause of dam safety are vital in ensuring the well-being of current and future generations. As we conclude, let us take our commitment to working together diligently to ensure the proper management and safety of dams. May our collective efforts contribute to safeguarding lives, properties, and our precious environment. Wishing you all a pleasant evening. Once again, thank you for being a part of this important dialogue. Thank you very much and good night.
Thanks, Janaki. Thanks, Bhadra. Take care, guys. Bye.